Hi, this is Jim,
This is Kathy.
And this is Owen.
and this is Shall We Play a Game?
This is our director's commentary.
So the project goals of our project, I don't know why I said that, it's redundant. Anyways,
And repetitive.
also that too, thank you, is to create a model for the time of flight of the Aerobie. And Kathy, you did.
Sorry, we
Oh.
did that using VPython to try to model the flight of the Aerobie.
We then put it into Tracker to put a computational model on it.
And I made a very poor attempt at creating a force pie chart to calculate the lift and drag.
Sounds good.
All right.
I like it.
Project limitations. We had a very limited time frame to take data and to test that data and to create models. A total of about 5 hours. You'd think that'd be a lot of time, but actually really isn't. So since we were stuck to a very limited time frame, we couldn't test the angular momentum and angular speed and thus the precession of the Aerobie as it was in flight. And similarly, well, not similarly at all, I don't know why I said that, parallax issues when we're actually filming, mostly because I can't throw. Kathy is our star thrower, right?
You say so.
She went pro doing, what was that? You were
Ultimate Frisbee.
ultimate
yeah.
Frisbee. Full contact ultimate Frisbee.
That's
And,
from something, isn't it? If you say so, Jim. Isn't that from something?
I don't know.
That's okay.
I think that's Star Trek.
Okay, maybe.
Okay, I don't know.
All right.
Okay, supposed to say damn it, Jim. All right, data issues in Tracker, which Owen took care of. All the data issues in Tracker are his fault.
Yeah, it's true. The video was ridiculously long, and I didn't figure out how to clip it down in time. So we just pushed through, and it was pretty difficult with Tracker to have a huge image or a huge video file. Things were pretty glitchy. Eventually, we got over that. I figured out how to use QuickTime because I'm brilliant. So.
And Kathy, do you want to talk about the limitations with VPython?
The limited time that I had to remember what I once upon a time learned,
A year ago?
or more.
And
Yeah.
start from scratch to create a model from a heavy programming intensive software. All right. So the materials, which is actually awesome. You need something to throw at somebody else's face. So that would be an Aerobie. A Casio X-Lim. Hello.
I was like, why is that door open?
So this is Dwayne. We're recording. Dwayne, say hi to everybody.
Hello.
Okay. Dwayne just came from England. So we use the Casio to record and do all the filming and take pictures of us. We use Tracker. Well, actually, Owen used Tracker to take all the data and create the numerical models. And Kathy used VPython to model using a 3D programming, create a 3D programming model. All right, so here is some of the recorded data, and you will see that I do not know how to throw. So it's very slow motion, but we could probably back it up a second.
That was pretty good form. Don't be hard on yourself.
Well, look at this. See, the problem is with this is right here you start to see a hole start to appear, and that means that the Aerobie is veering off. In the very beginning, it's very level and it's going up nicely. But as the lifetime starts to go by, right here you start to see a hole appear. That means it's moving towards the camera or away from the camera.
We did so many throws, we really don't know which it is in this particular video.
And I just noticed I have a bald spot emerging on the top of my head. So
that's the front of your head in the picture right there.
Right, but
that would be your face.
I leaned over a little bit, and I can see
Oh.
the bald spot appearing. So I've got to fight that demon later tonight.
Okay.
It's when I'm crying at midnight. I'll call Kathy. I'm still pretty, right?
Yes.
Yeah. Fine. This is a very simplified model of the forces. Forces on the Aerobie. It's not at an angle, which is what happened in all the throws. It was always leaning back ever so slightly. But you get the gist. Lift, drag. This obviously assumes that the Aerobie is being thrown to the right, even though the video you just saw shows it being thrown to the left. And of course there's gravity.
And we drew a couple, actually, I drew a couple acceleration vectors because I like to do that just to add some depth to my force diagrams. So that's basically the theory behind what we're doing. Right. And data analysis. Take it on.
All right, so here's a typical Vx motion graph, velocity in the x direction. This one has positive velocity to the right. It happens to be slowing down as time goes on. The actual equation shows velocity to the left, but that's okay. We're just showing a typical Vx graph and a fit. Pretty messy data, but a reasonably straight line. Any comments? This is the y versus time graph. We didn't do a Vy versus time because the velocity there was so little variation in y that the error was dominating the Vy velocity. So we went to the y, that way we could get a bigger average, if you will. We could model it with a parabola and it would just fit through all those points. And it's a rough fit, but it works. Here you notice that the acceleration is negative 0.068 meters per second squared, which is definitely not 10 downward. So there's definitely some lift involved. And
Kathy created this wonderful computational model.
Yes, I couldn't figure out how to make it understand that I wanted it to look like a Frisbee, so I used one of David Weaver's programs and convinced it that a ball was a hoop. And here it is.
I think it looks pretty good.
Yep.
That's how I throw.
Yep. It was very curved to the
That's our first rough attempt.
I think my first frisbee did get embedded into the ground like that.
Yeah.
But it actually looked really good.
It's really good computational. Here is the computational model done in Tracker, which Owen did.
So if you'll plan, so there are three models right here. The lower model that's diverging right now, that is if this projectile was just falling under gravity. There is also two other models. Obviously it diverges from the real actual Aerobie. You'll see it start to diverge from this blue line, which is our other model, which is just a very rough, it comes from the fit of the data using some lift and some drag, just the data we got from it. But it's constant forces with time. And you actually get to see by the end, there's some deviation from the Aerobie and this constant force. So it must not be constant in time.
So what we learned from this is a few things, mostly limitations, is that we do have a parallax issue, which we probably can't resolve between the drag force and, or whether it's really a parallax issue in the x direction. Which creates an issue in the x direction. We have data point inaccuracies possibly and some scaling issues. And also I can't throw.
And there you have it.
Pretty good. Thanks for watching our show.